Hey everybody, this is a demonstration of the Karpenter Provider Cluster API, which is kind of an experimental proof of concept that we've put together to demonstrate how Karpenter could be used on top of Cluster API. So I'll show you a little bit about the setup that I have here, and then I'll run Karpenter and we'll see it do its thing. So I'm using the Cluster API kubemark provider, which allows me to do all this kind of in a virtual environment. So if we look, I'm using kind, and we can look at the clusters that have been created. And I've got two clusters here. One is called kind, and that's my management cluster that I'm using for Cluster API. And the other is called KMCP, and that's the workload cluster that I've created for kubemark. So if we look at the Cluster API objects, we can see there's a cluster there. We can see that we've got one machine in our cluster currently. It's a control plane machine, and it's being hosted by a Docker provided machine because kubemark does not actually run the pods. So we need a control plane that's actually running our pods. And then we can also see that there are two machine deployments in this cluster, both currently at 0 replicas. The one marked MD0 is not marked for Karpenter inclusion, and the one marked MD1 is marked for Karpenter inclusion. And what I mean by that is that there is a special label that we can add onto machine deployments to let Karpenter know that this is a machine deployment that should be included in its activities. And when I talk about that, it's important to know that when running on Cluster API with Karpenter, the cluster itself, or the management cluster, becomes the infrastructure provider in the same way that OpenStack might be the infrastructure provider on another cluster. So when Karpenter needs to query to find out what instance types are available for it, it needs to look at the machine deployments that are available, and those that are marked up will tell it what type of instances that are created. So let's look at what the spec for this machine deployment looks like so we can learn a little bit more about how Karpenter identifies these things. So first we can see that there is a label here that we've set up that is telling Karpenter that this is a member of its activities. And so Karpenter should consider this as one of the instance types that it could use. Then we're using the scale from 0 annotations from Cluster API and the Cluster Autoscaler to be able to inform Karpenter about the shape of the machine that will be created. So in this case, we're telling it there'll be 100 max pods, there'll be 128 gigs of memory per instance, and there will be 16 cores of CPU. And we're also using the label option here so that we can tell Karpenter that this label will be on the nodes that are created. And this will be important for how we set up the node pool for Karpenter. So let's look at that real quick here. Karpenter uses a couple different types of objects to get itself working. One of them is the node pool. And in this case, we've made a very basic node pool. The only requirement on nodes is that they have the architecture label and that value is AMD64, which is what our cluster will create. And then the second thing we're telling it is where to look for the node class that will define how Karpenter can create instances or how it can find instances. And so in this case, our node class is something we call Cluster API node class. So let's look at that to see what that looks like. So this is a very basic implementation here. I've given it the defaults with no added information. If I wanted to, I could specify as the single parameter to the spec a label selector that would instruct Karpenter on further constraints that it should use when searching for machine deployments. So in this way, you can make multiple Cluster API node classes to target different groups of machines based on your needs. But in this case, I'm going to use basically the empty label selector, which means select everything. So Karpenter will select everything that has the member label that we showed in the machine deployment. So let's put these into our workload cluster. Okay, so now our workload cluster has the proper objects for Karpenter to operate. Let's start Karpenter, and then we can get it to start working. So the way I want to run Karpenter in this respect is to have it look at the workload cluster for its nodes and pods and Karpenter-specific CRDs, but I need it to look at the management cluster to find the cluster API-specific pieces. So there is a flag that we've created on the controller that allows you to inject a kubeconfig for the management cluster. And this is where Karpenter should find the cluster API objects. So let's start it now. Okay, so now Karpenter has started. It's initialized its controllers, and it's basically waiting for something to happen. It's waiting to see pending or unschedulable pods that it can do something with. So let's make that happen. I've created a small workload here that will create 20 replicas of this basically sleep pod. And you can see that each one requests 4 gigs of memory and 1 CPU. So with 20 replicas and the stats from our machine deployment, we should know that each machine will have 16 cores and 128 gigs of RAM. So this should force the creation of 2 instances that will schedule the workload. Okay, so we've created that, and if we go over here, we can see that Karpenter is already reacting. And what it's doing is it's attempting to create these nodes for us. So we can see that here in this info message, we can see that a node claim has been registered and that it has this provider ID. And we can see a little lower down that another node claim has been registered and it has this provider ID. So it looks as if 2 machines have been created for us. So let's go back and look at our management cluster now to see what we have. Great, this is exactly what we expected. 2 machines. And if we get the machine deployments, we can see that the machine deployment we expected has been increased in replica count. Furthermore, if we get the pods from the workload cluster, we should see that all of our pods are now running. So this is a basic demonstration of Karpenter working on Cluster API. It is manipulating the Cluster API objects to make action happen in the cluster. As I said, this is currently an experimental proof of concept. Hopefully we'll have it in Kubernetes SIGs orgs in the near future, and it will be open for contribution from everyone. So thank you very much.